Lesson 56, identify, write, and graph direct variation. First off, let's look at what direct variation is. Direct variation is where y varies directly as x, which means that y equals kx, and y is the dependent variable, x is the independent variable, and k is the constant of variation. So when x increases, your y is going to increase, or if your x decreases, your y value is going to decrease as well. So when we think of direct variation, think of your x being your input. You put an x in there. The equation tells you what to do with that number, and then it gets you another number. So your y value. So the k is always going to be your constant. This would be like your slope in slope-intercept form. So to find the constant, we'll see that you just solve for k. So if you're starting off with y equals k times x, to get k by itself, divide by x. So to find the constant from given an ordered pair, you take your y value and divide it by your x value. Let's take a look at an example here. It says put y equals kx or k equals y divided by x if possible, and then find the constant. So we want to identify if it's in direct variation format. So this first one, y plus 8x, we want to determine if that's direct variation, so I'm going to solve for y. So I'm going to subtract 8x on both sides, and I have y equals negative 8 times x. That is in this format, y equals kx. So yes, this is direct variation. And then I have to find the constant. The constant equals a negative 8. Second example, y divided by 10 equals x. I need to get y by itself, so I'm going to do the opposite of dividing by 10. So I'm going to multiply by 10. Do that on both sides. I'm left with y equals 10x. That is direct variation. The constant is 10. So to find the constant again, just identify the number right in front of your x variable. The third example, solve for y. So I divide by x on both sides. I have y equaling 6 divided by x. Now I can see my two forms of direct variation. I can either have y equals k times x, or I can have k equaling y divided by x. Since I have y equals 6 divided by x, no, this is not direct variation because I can't divide by the x variable. At least if I'm dividing by the x variable, it has to be divided by the y variable. So the y divided by x, not the constant divided by the x. Other examples, y plus 5x equals 1. So I need to subtract 5x on both sides. And I have y equals negative 5x plus 1. This may look like it's in direct variation, but it's not. And the reason why it's not is because of this 1 at the end. So it just has to be strictly y equals k times x. Next one, y divided by 7 equals x. Multiply by 7 on both sides to get y by itself. I have y equals 7x. Yes, that's direct variation. Constant equals 7. And this last one here, get y by itself. I divide by x on both sides. And I'm left with y equaling 1. Because x divided by x is 1. So no, this is not direct variation. There is no constant. And we don't even have an x variable left in our answer. Other examples here, y minus 12 equals x. I'm going to add 12 to both sides. I have y equals x plus 12. No, that's not direct variation because I'm adding over here. It can only be multiplication. And the last one here, multiply by -3 on both sides. And I'm left with y equals -3x. Yes, this is direct variation. My constant would equal -3. Next one, divide by 3 on both sides. Y equals x divided by 3. Now this, it looks like it wouldn't be direct variation, but yes it is, and here's the reason why. If I were to rewrite y equals x divided by 3, it's really y equals 1/3 times the x. And since I'm multiplying a number times the x variable, that's in y equals kx format. So my constant would actually be a 1/3. So keep that in mind because it may look different than all the other ones. But really, when if you're divided by a number, you're really multiplying by a fraction. And this last one here, to get y by itself, I divide by 2x. I'm left with y equals 8 divided by 2 is 4. I have 4 divided by x because remember the x is still on the bottom. This is not in direct variation because I can't take a number divided by the x. Moving on to the next kinds of examples. Identifying direct variation from ordered pairs. So here, they're going to give us the ordered pair, and we're just going to take our y value and divide by our x value. For it to be direct variation, all 3 pairs of ordered pairs must have the same constant. If one is different, it's not direct variation. So -14 divided by 2 gives us a -7. -35 divided by 5 equals -7. 21 divided by -3 equals -7. So yes, they're all the same. That is direct variation. Next one, 4 divided by 2 is 2. 5 divided by 3 is 5/3. 7 divided by 5 is 7/5. I can't reduce those anymore. They're not the same, so no, it's not direct variation. Last one here, 12 divided by 3 equals 4. 8 divided by 2 equals 4. 4 divided by 16 equals 1/4. No, this is not direct variation because the last one does not have the same constant. Let's check to see if the ratio of y divided by x is the same for each ordered pair, except when x equals 0. So I take 6 divided by 4. I divide by 2 halves. That gives me 3 halves. This is 3 halves. And 36 divided by 24. If I divide that by, we can divide that by 4/4. That gives us 9/6. Divide that by, actually make this easier, let's divide this by 12/12. 36 divided by 12 is 3. 24 divided by 2 is 2. So yes, this is direct variation. Next one, we got 10 divided by 3 is 10/3. 40 divided by 12, I can divide this by 4/4. That gives us 10/3. 30 divided by 9, divide this by 3/3. That gives us 10/3. So yes, this is direct variation. Last one, you got 4/10, which is the same as 2/5. 6/12 is the same as half, and 8/14 is the same as 4/7. They're all different, so no, that's not direct variation. And writing an equation given a point. So here we want to write an equation in direct variation format. So to write the equation, use the ordered pair that is not the origin. So you cannot use 0, 0. Find the constant k in the equation y equals kx. So it says write an equation for a direct variation includes the point 624. So I start off with y equals kx. I substitute these numbers in. My y is 24. I don't know my constant, that's what I'm finding, but my x term is 6. So to solve for x, solve for k, I divide by 6 on both sides. Since my constant equals 4, I plug that back into this equation. So y equals 4x would be my equation for direct variation. So all you're doing with the point is finding your constant and then putting it back into the equation y equals kx. Next one, write the equation for this one. So really we could just take our x and your y, y and your x, divide them. This will give you your constant. So our constant would equal 6. So y equals 6x would be our answer. Write the equation for this example. So my y divided by my 9 will give me my constant. Constant would have to be 8. Plug that back into our equation. So y equals 8x. And another one, the distance a person runs varies directly with the time spent running. If a person runs 12 miles in 2 hours, how many miles will the person run in 3 hours? So I'll give you some options. You can use y equals kx. You can do rate times time equals distance, or you can set it up as a proportion. If we were to do rate times time equals distance, we would have the rate times time equals distance. The distance was 12 miles. The person runs for 2 hours. We need to find the rate. So to solve for the rate, you divide by 2. The rate would be 6. And our rate is like our constant. So if I put that back in my equation at a rate of 6, and they run for 3 hours, what's our distance? Our distance would be 18 miles. So that's using rate times time equals distance. If you were to set up as proportions, you can do it as miles over hours equals miles over hours. And so if the person runs 12 miles for 2 hours, that would be the same as doing how many miles in 3 hours. And so I can cross multiply. 3 times 12 is 36. 2 times n equals 2n. Divide by 2. N would have to equal 18 miles. And that's what we had over here. So there's a couple of ways of solving those types of problems. Next one, the amount of water in a swimming pool is directly proportional to the time the water is left on. If the hose supplies 200 cubic feet of water per minute, how many cubic feet will be in the pool in half an hour? Now the key part is half an hour per minute. You need to make sure that the time is in the same units. So if we do, since it says the amount of water, so the amount, this is like your y, directly proportional to the time. This is your x. So if we do y equals kx, we have an ordered pair, which is the 200 per minute. This is just in 1 minute. So we would have our 200 would be for our y. We need to find our constant when our x is 1. Well, 1 times k is k, so k would have to be your 200. If I plug that in back in here for my constant, what does y equal when the constant to 200 is multiplied by my x? Half an hour is 30 minutes. 200 times 30 would give us 6,000. This would be 6,000 cubic feet. That is one way of solving with the equation. You could set it up as proportions. So 200 cubic feet over 1 minute is the same as how many cubic feet in 30 minutes. Well, I know that 1 times 30 gives you 30. So I multiply by 30 on top. That will give you your 6,000 cubic feet. Next one, the number of boys in a class varies directly with the number of girls. One class has 6 girls and 18 boys. How many boys will be in the class with 8 girls? So I would set this up with proportions. So 6. Actually, let's do the number of boys in a class varies directly. So we'll have boys first, just because this is our y. And we want to use y divided by our x. This is our y, this is our x, this is our x. We need to find our y. So 18 to 6 is the same as how many boys? We don't know, but we have 8 girls. For this one, I would actually reduce 18 over 6. So if I reduce 18 over 6, divide that by 3/3, that would give me 6 halves is the same as b over 8. And I know that 2 times 4 gives me 8. So that means 6 times 4 will give me the number of boys, which would be 24 boys. So again, there's multiple ways of solving that one. That one I just use proportions. Next one, the grocery store sells 3 pounds of lemons for $1. Graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. For this one, it would be quicker, instead of drawing the graph, we'll use a proportion for this one. So you can do 3 pounds for $1. It's the same as what is the cost of 12 pounds. Well, I know that 3 times 4 will give us our 12. So 1 times 4 would give us our amount of money. So our amount of money would be $4. Next one, if the grocery store has a special on lemons this week for 3 pounds for 85 cents, what is the cost of 8 pounds of lemons? So we have 3 pounds, cost for 85 cents. What is the cost of 8 pounds? So here, I would just cross multiply and divide. So 0.85 or 85 cents times 8 would give us $6.80. And this would equal 3n. Divide by 3. You're going to get a repeating decimal, so we round it to the nearest cent. So we would get $2.27. And our last problem. The volume of a box with a fixed base area varies directly with its height. The box with a height of 4 centimeters has a volume of 29 cubic centimeters. Graph this relationship. We're not going to graph this, we'll just use equations. And then use that to estimate the graph, use the graph to estimate the volume of a box that is 3 centimeters tall. Again, the simple way would just be, instead of doing graphing, we're going to set up using proportions. So the volume, our y, of a box with a fixed base area varies directly with its height. So our height is our x. So our volume is 29, and the height is 4. That's going to be the same thing as what is the volume when the height is 3. So I take my 29, multiply that by the 3, you get 87 equals 4V. Find the volume, divide by 4. So 87 divided by 4, volume would equal 21.75. If we wanted to estimate that, around that, we could say this is about 22 cubic centimeters. So that's our lesson today on working with direct variation.